Hello, children. Welcome to the new year. I want to point something out to you, if I can. I still don't have a new computer, by the way. Santa was not good to me, but New York State might have been. We just got to make sure we get the ruling from our school district, but it looks like we're going to be able to teach you guys with Algebra 2 Trigonometry, which is great news because first of all, we're really good at teaching Algebra 2 trigonometry. Our kids do amazing. But not to mention, there's lots of review and review tests, and we know exactly what we're going to be getting. Well, mostly know exactly what we're going to be getting. So you guys should be pretty excited about this. So let's get going. This will be our first video on basically old material from last year's Algebra 2 Trig, not Common Core stuff. So let's see how you guys do. This first things are very simple. We've already done some things like this. It's just kind of a basic let's get our brains going back in review. Should have done this stuff in Algebra 1 probably. So anyway, we're going to do these multiple choice. Now there's a couple of different ways to do multiple choice. There's the cop-out way or the actual way. And I'm going to show you the actual way first, and I'm going to show you the other way in a second. Hopefully this pen works. So what we're going to do is we're going to factor the numerator. All right, you know that if you factor, the first thing you're going to do is look to take out a GCF. So my GCF in the numerator is 9x to the fourth. And when I do that, what I'm left with is 1 minus 3x squared. All right, so now I take out my pen, I start canceling. By the way, it's a 1 here, and most kids will forget that 1 here, because when I redistribute 9 times 1, gives me this first term of 9x to the fourth. And then 9 times this 3x squared gives me my 27x to the sixth. All right, so 3 divides evenly in the 9 3 times. These 3 x's cancel with 3 of these, leaves me just the 1x. So there's my answer, 3x, 1 minus 3x squared. Well, how do you cheat? Well, you take out this calculator thing here. I'll try to do it. So my bald head's not too much in the way. My bald head's going to be way in the way there. So let me just do it this way. Oh. That's weird. Hey. I guess I can have that over there. But I know my bald head's sitting right there somewhere. Let's see. So what we're going to do is go to calculator mode. And we're going to take any value. Now, I like to take obscure values like 3.2 and store it in x. Don't ever pick 1 or 0. You can't pick anything that's going to make the denominator undefined as well. That will give you a big problem. So then we're going to just type in the original problem. The original problem was 9x raised to the fourth minus 27x raised to the sixth all over 3x cubed. And we're going to get like 4 as our answer. Oh, negative 285.3212. Actually, that's probably not even correct. Let me just, oh yeah, okay, maybe it is correct. All right, so then I'll type in the answer we got, which was 3x parenthesis 1 minus 3x squared. Now, if everything's right, it should be the same stupid answer. Invalid multiplication. What are you talking about? Implied multiplication. Why does it not like these? Why can't I put 3x? That doesn't make sense. Never done that before. That's new. Okay, then. Let's just delete that then. Apparently it doesn't like that. 3x. Maybe we got to do times here, parentheses. That would be dumb. 1 minus 3x squared. Better. All right, well, anyway, I don't know what's going on with the calculator, but that's another way to do the problems is to check them using your calculator. Now, I'm not going to do that anymore just because it's, to me, annoying and time consuming. But on the day of the test, you would be in your best interest to make sure you actually do that and verify that, yes, in fact, you do have the correct answer. All right, so this one here, what we're going to do is take out a 2x. When I take out a 2x, I'm left with an x minus 6 all over x minus 6. These x minus 6's cancel, and I'm left with 2x. Oh, and over here I'm left with 1 minus 3x squared. Gotta get off this pen. All right. In the numerator, I could take out a 25, and I'm left with x minus 5 all over x plus 5, x minus 5. All right, x minus 5's cancel, and there's what I'm left with, 25 over x plus 5. Over here we factor x minus 5, x plus 3, all over, take out an x, and I'm left with x plus 3. Well, the x plus 3's can cancel, and there's what I'm left with, x minus 5 over x. I feel like I've done these problems before. So here we go. We're going to factor. In the numerator, it's going to be x and x. Because this is a negative, I know one's going to be positive and one's going to be negative. And you got to add up to -1, which means it's got to be +2 and -3. And then the denominator, since this is a positive, they both are going to be the same, and they're both going to be negative. -2, -3. Goodbye. See you. X plus 2 over x minus 2. Oh no, no multiple choice. The numerator is probably really easy. It's just the difference of perfect squares. By the way, do y'all liking the beard? This is me just being lazy over Christmas break. +1, -1. On the next video today, it will be gone, I hope. That would mean I had the ambition to go upstairs and shave. So x plus 2, x plus 1. These cancel, and my answer is x minus 1 over x plus 2. Remember, anytime you have adding and subtracting, you cannot cancel. All right, so let me blow this up because I want to not like blow it up physically, but so you can see it better. So what we're going to do here is, since there is no, oh yeah, my eyes are burning today. I don't know why. Since there is no adding and subtracting, this is all multiplication, being multiplied by something, got some division here, I can just start dividing out common factors. I can start canceling stuff out. So let's do that. Let's start with the numbers. 2 goes into 8 4 times. This 4 cancels with this 4. Okay, so the numbers are done. This 1x cancels with one of these. It leaves me 2. This y easily cancels with this y. These y's, there's 2 of them, cancel with 2 of these. It leaves me just that one y there. So if I look, the whole entire denominator is gone. That means no more fraction. So my final answer is 7. Now I've got x squared here. Let me highlight it in yellow. I've got x squared here and x to the 4th. So that would make, if I'm multiplying x to the 6th, y. There's that answer. Over here, since I have adding and subtracting, the first thing you must do is factor. So in this first one, I can take out a 4x, and I'm left with 1 minus x. Hold on a second. What number is this? 8. What number is this? 9. I think, well, we'll see. This is going to be x minus plus 3, x minus 1. Yep, we're going to have the problem right here. All right, so let me come back to this problem, and let me go do this problem first, and then I'll come back to that one. I knew I had these out of order. Not out of order, never mind. You'll see in a second what I'm talking about. So division, or multiplication of these fractions, is nothing more than basically same problem right here. Factoring and then dividing out the common factors. So here I can take out a 3x, and I'm left with x minus, left with 1 minus x. Basically the same as that last problem, you'll see in a second. This one I can factor, and it's x plus 5, x minus 1, kind of similar to that last problem. And this one's going to be x plus 5, x minus 4. All right, so if the parentheses match exactly, like this x plus 5 matches with this x plus 5, and this 3x matches with this 3x. Here's where you have your problem, and you've got to start recognizing these things. Those two things are backwards. And I've had it already on a spiral a couple times, and those of you who come see me, you know what this is. But basically, if I was to put in a 5 here, and a 5 here, just sub in a 5 for x, I would end up with negative 4 over positive 4, which is negative 1. Negative 1. If I was to put in a 15 here and a 15 here, I'd end up with negative 14 over positive 14. If I was to plug in a 0 here, which you should normally never plug in a 0, but you do, I get 1 over negative 1. 1 over negative 1. So this is negative 1 again. So because these are backwards, and this is only true of multiplication, we like to call this the negative 1 rule. Yes, they cancel each other out, but they make a negative 1. Now that's not subtraction, that's multiplication. So here the final answer would be negative x minus 4. And if you don't like that, you can distribute this negative 1 by saying, okay, it's really negative x plus 4. So everything cancels out, but there is one special canceling rule, and that is if you have, it doesn't matter what the number is. Let's take 6 minus x over x minus 6. If they are backwards like this, you get negative 1. Let me do it in a general case. How about this? X minus y over y minus x. As long as they're backwards from each other, this is going to always equal negative 1. And I call this the negative 1 rule. But rule is really in quotes. It's not really a rule. It's just Krauss's rule of negative 1s. After I do Krauss's rule of negative 1, I like to go back to my sponsor, of which I've made no money. And I'm about to switch sponsors. So you better jump on board right now. Oh. So let's go back up here and you'll see why I stopped. Because I needed to address that rule. Because you see it right here. Here it is right here. We have the same exact factoring actually as the last one. So this one is x plus 3, x minus 1 all over 4x. So it's basically the same exact problem. So the 4x's cancel. The x plus 3's cancel. They just cancel. Now I have a 1 minus x. Oh, no, this one's actually not a problem at all. Because I have an x minus 1 here and an x minus 1 here. So those actually just cancel. So my answer is 1 minus x. Interesting. I didn't see this. I could have done this problem actually. So I tricked myself. I forgot I did that. It's been a while since I did that problem. Let's go 9 we did. Oh, I think 10's over here somewhere. Nope. 10 must be below. There it is. So hopefully So let's just do this. Now, division is, if you remember from 3rd grade or 5th grade or whatever, if you've got 3/4 and you're going to divide it by 9/16, what you need to do is take this fraction right here. It's always the fraction that immediately follows the division symbol, and flip it and multiply. So what happens is this problem becomes 3/4 times 16/9. And then I can go through and start simplifying. For example, 3 goes into 9 3 times. 4 goes into 16 4 times. So my answer is 4/3. Ooh, didn't know that was going to happen. So that's what we're going to do over here. We're going to take this problem, it is a division problem, and we're going to adjust it into a multiplication problem by taking this fraction and flipping it. So, nothing to do with the first one other than just factor it. So 7x, and in the denominator, this one right here, I can take out a 2x, and I'm left with x minus 5. Now I'm going to work on this one. I'm going to work on that. Now, because it's turning into a multiplication problem, that one's going to come down here. And the only thing I can take out is an x. And I'm left with x minus 6. And then I'm going to work on this one, and that goes up here in the numerator, and that's going to be x and x. Signs are going to be the same because this is a positive, and they're both going to be negative. And -5 and -6. And I start dividing out common factors. This x minus 5 cancels with this x minus 5. You can go from any numerator to any denominator as long as it's all multiplication. This x cancels with this x. So I'm left with 7/2x. Now, this is division, and some of you struggle with ones look like this. We've got to remember, this is really, any number can be written over 1. So when I take this and flip it, that 1's going to come to the top, and that thing is going to go to the bottom. So, and we're going to change it into a multiplication problem. Sometimes it's easier to think about this one first. We'll put the 1 up here, and we'll take out an x here, and I'm left with 3x plus 5. Besides, that factoring was very, very easy. And you're going to probably see that that's going to help us out in just a second. Man, my eyeballs are killing me. 4x squared. And this one, 3x and 2x. Now, if I'm a cheating man, I see a 3x minus plus 5 here. I'm going to guess this is probably plus 5. And if that's plus 5, then this would have to be minus 3. But I'm going to check. -9, positive 10. That makes 1. Perfect. All right, so this 3x plus 5 cancels with this 3x plus 5. And I believe that's it. So the numerator, I just get these two things multiplied. So that's just 2x minus 3. Leave it in parentheses so you don't do anything heinously dumb. And in the denominator, we just multiply. We're going to multiply these two things. And I get 4x cubed. All right, we're going to divide. We flip and multiply. You'll notice I'm probably doing more division problems than multiplication because division is multiplication, or at least it turns into multiplication. In this denominator, you can just take out a 5, x minus 4. Now remember, this is the one that gets flipped. So now I'm going to work with this one. Put it in the denominator, x minus 2. This one's going to come to the top, x. Both this is going to be, the signs are going to be the same. They're both going to be negative, 2 and 4. I mean, all things cancel here. This x cancels. This x minus 2 cancels. This x minus 4 cancels. And I end up with just 4/5 as my answer. All right, this is going to be the last problem. Oh, now, this one bothers kids. And it bothers you because you can't see it for what it actually is. So what I'm going to do is I'm going to highlight these two things in two different colors. So what I have here is really this. If I just move this here, this thing right here, this line here is really the division symbol, right? It's this fraction divided by this fraction. So that's really this problem. Well, then what would I do? I would flip and multiply. All right. Now, let me point something else out to you. Now that you see this, now let me get rid of all this fancy stuff here. And I want to show something else. This right here, that right there should scream bells and whistles in your head. It's backwards. Normally, we're used to seeing that as x squared minus 4, not 4 minus x squared. So what I want you to start looking for is things like this, because this is going to be the -1 rule. It's like almost guaranteed somewhere in there, because you have something that's backwards. I'm going to say it's backwards. And I don't really, it's just backwards from what we're normally used to seeing, that it's really got a very good chance it's going to have the -1 rule. So keep that in your brain. Oh yeah, probably going to have the -1 rule. All right, so remember we took this and put it over here. So let's factor this thing. It is in fact backwards, so it's going to be 2 and 2 plus x and minus x. Because the number came first, the number has to come first down here. Now let's factor this denominator. That's pretty easy. It's just x plus 3, x plus 4. Now this one, remember, this one comes down here. So I take out a 2 and I'm left with x minus 2. And this numerator is pretty easy. It's just x plus 3. All right, so x plus 3 cancels. Now, this is going to cancel with this, but because one of them is backwards, they cancel. And what I do is I put a -1 in the numerator. Now remember, it's not -1, it's times -1. Now I'm done canceling things out. I'm done finding out common factors. So in the numerator, what I have left over is -1 times 2 plus x. And in the denominator, I have 2 times x plus 4. And you cannot do anything else with that. That's it. All right, kids, I believe that's all I'm going to do for you. I believe this didn't be too difficult. The rest of it's just straightforward, simplifying, factor and simplify, factor and simplify. All right, good luck. You guys are awesome. Keep rocking it. Hey, good news, good news. Thank you, New York State. We're going to rock this Algebra 2 Common Core test. Bye.